My name is Shin-Ichi Tanabe from Waseda University, Tokyo, Japan. Title of my presentation is Utilization and Evaluation of PECS in a Research Facility Office in Japan. So this is the T Innovation Center. The project was planned as a new research and development hub that consolidated the former research institute of Takasago Thermal Engineering, which celebrated its 100th anniversary in November 2023, along with the purse of the development department from its headquarters. So this is T Innovation Center. Location is in Tsukuba, Ibaraki, Japan. The height is the two-story building, and the target office, the second floor of activity-based working. So the construction project began in November 2015, was completed in January 2020, and commenced operation in March of the same year. The building detail are shown in the bottom right. So it's a long, light, two-story structure with the site area of approximately 22,700 square meters, and the total floor area of office building is 4,750 square meter, and the laboratory building is around 6,000 square meter. So energy systems, so I will explain in the later. So, and we have a certification for Japanese BLS and LEED and CASB Wellness Office. And recently, we received the ASHRAE Technology Award for 2024 for commercial building new construction. So here's an overview of strategic towards carbon neutrality and zero energy building. To simplify, I will explain in terms of 4 key points. 1, architecture plan, 2, heat source and energy plan, and 3 is indoor environment planning, and 4 is a contribution to the community and transfer to the technology. So the blue one is the design of incorporated natural ventilation and daylighting while achieving solar shading and high thermal insulation. And point 2, the pink one is the renewable energy is a key focus with the introduction of a biomass, gasification power generation, and solar power generation, and large-scale storage batteries. Its groundwater is also used for air conditioning. So green one is a PECS. So indirect lighting system and natural ventilation are employed. The 4th point is brown one. The garden surrounding the center is open to the community, and the cafe inside the building serves as a communal communication space. So I'm talking for the office building from now. So this is a net zero energy system. So the solar panel is 200 kilowatt, so around 2,000 square meter. And also we installed a biomass CHP and 40 kilowatt for the 2 unit. Wood chip fuel combined heat and power system. So the sunlight produced through the PV to electric, and wood chip, the biomass, heat and cold, cool, and groundwater, we use cool water. And also for the storage, we have a battery, and the lithium-ion battery is really big at the 430 kilowatt hour battery. And also NAS battery, we have a different kind of battery system in this building. And this is energy consumption simulation for the office building based on ASHRAE 90.1 indicate that the design value is 421 megajoule square meter per year. but design value is minus 130 megajoule per square meter per year. So achieving is minus 131 energy saving compared to the ASHRAE standard value 421. So when operating the one biomass CHP unit, a post-completion survey in fiscal year 2021 revealed that the continuous operation improvements result in additional 14.3% energy reduction. So including electricity from the solar panel and the two biomass CHP unit. So primary energy consumption is minus 263 megajoule per square meter per year. So achieving 162 reduction from the standard value. So resulting in the net, also resulting in the net zero emissions. So this is a photograph for interior atrium, where the gentle heating and the cooling system are implemented in this area. So in office, employees can freely choose their seats. So we call activity-based working. So while equipped with a comfortable and efficient air conditioning and lighting system. So outdoor air is supplied indoors after temperature and humidity adjustment with the DOAS system. So building a sanitation code we have in Japan, so they require to keep less than 1,000 ppm CO2 level. So sensible heat load are managed by fan coil unit, ceiling radiant panels, and also personal air conditioning, and also hot floor water flow heating system. So numerous human position detectors and thermal piles installed on the ceiling, so monitored via central system. So indirect lighting and the daily lighting control are employed for comfort and energy saving. So here, three types of the PECS are applied. So one is a ceiling-mounted PECS system. The second one is partition PECS system, and also desk PC system. I will explain in more in detail. This is a ceiling install PECS system. So the surface is a radiant cooling and heating system. This is a ceiling install PECS system. And the ceiling install PECS system, we apply for DC fan with a 3.1 watt. It's very low energy consumption for the fan. And inside we have a coil with cooling coil and also electric bulb. So outlet maximum air volume is 236 cubic meter per hour. So maximum cooling capacity is 470 watt. So also a mobile phone can operate for on and off and other control for each PECS system. So this is a partition PECS system. So outlet is above the desk from the partition, and also air volume adjustment is left hand. So this is the partition PECS system. So outlet air volume maximum 130 cubic meter per hour. So air volume adjustment, and also we are using for DC fan. So only 6.6 watt for the fan. And also cooling coil is installed in the partition. And also this partition is possible to operate with a mobile phone, and also easy to use. And the last one is the desk PECS system. So this is simple. We installed under the desk, outlet, and air direction adjustment system is installed. So air direction adjustment is easy by manual operation, and DC fan is only 1.9 watt, and the cooling and heating coil in the inside. So outlet air volume maximum is 50 cubic meter per hour. So cooling capacity is maximum for 70 watt. So also this one is possible to controlled by the mobile. Here's the office building plan, the second story. So there are 4 zones of A and B and C and D. Zone A is more comfortable condition control. So here, seating unit, we put 57 units, partition of 30 units, and desk is 28 units. So zone B is something like adaptive place. It's a more wide range of temperature humidity. So seating 34 units, partition 10 units, desk 18 units. So zone C is also more rough control of temperature humidity. So seating 36 unit, desk 8 unit, and zone D is we installing only for the seating PECS system, so 38 unit there. We reported for season usage rate of the PECS system. We investigate for year around. So people use during the summer. The usage rate is higher during the summer season, and they like seating and partition and deck system. So during fall and winter, so this PECC system use, I think that they use for the heating purpose, use personal PECS system. And the daily usage rate of the PECS, so I told you they're using in summer is more like other season, and they use in the morning. So when they enter from outside to go to the company, so 8 o'clock, 9 o'clock, they use PECS system summer. And also you can see for the after lunch, probably for the metabolic rate is higher during lunch, after lunch, so they use prefer to use the PECS system. So this is more used in the morning and after lunch due to the high metabolic rate. This is ambient summer condition compared with zone A and zone B. So zone A an office space, and zone B it's a buffer office space. I told you it's slightly rough temperature control. So zone A, so during the summer with the PECS, it's using in between 26, 28 degree temperature, and the buffer office space during summertime, winter time, they use this kind of system. So depend on ambient condition, and the people use the PECS system for different way. And once we prohibit to use the PECS system during a certain period, they complain. So, and we investigated prohibited during a certain period. The figure shows the percentage of satisfaction. Without the PECS system, satisfaction level drop significantly drop, where they reported dissatisfied without the PECS system. Well, this is a conclusion. So the T Innovation Center opened in January 2020 in the office building, and net zero energy and emission were achieved in 2021. The 3 types of PECS were installed in a different area. So system specification and usage pattern were investigated. During summer, PECS usage rate were higher, while in winter, desk type PECS provide the heating. PECS usage increased in the morning and after lunch. In zone A, PECS address metabolic heat, while in zone B, it compensates for the summer sensation. So prohibiting the PECS usage significantly increased dissatisfaction level. Okay, this is my conclusion. This is acknowledgement. So thank you very much for all collaborators. We continue to measure how PECS system operated in the real office. We may provide further data in the future. Thank you very much.